sort of looks like a break-even problem, but it isn't. In this case, you're just starting how the rent will behave when, or how the revenue will behave when you change the rent. And I have given you the revenue equation right here, so you don't have to derive it. If you took the business equivalent of 107, you would be writing these revenue equations from this kind of information. But in this case, I just gave it to you. Remember that revenue is price times, well, I'll put in for number, how about that? Price times number. So in this case, it would be the rent times the number of units rented. That would give you your revenue from this apartment building. So what is the price? Instead of just being a one number, we're studying it. Okay, right now you charge $800, but you're thinking of raising it $50, $100, $150. You're not going to raise it $15.60. You're going to raise it by increments of 50. Right? But you do know, okay, so this is the price part. Here is the number rented. Right now you have 20 people have rented it, okay? But if you raise it by 50, 2 of those apartments are going to become vacant and you won't be able to rent them. So you'll have to subtract 2 for every $50 increment you raise, and that's what's going on here. The X is not the number sold, it's the number of $50 you decide to raise the rent. For example, if X is 1, you raise your rent to $850. If X is 2, you raise the rent to $900. If X is minus 1, you'll drop the rent to $750. So you're going to try to figure out what's going on with the situation. What's the best rent to charge? Obviously, if you charge more, you might make more money, but if too many people move out, then actually that's going to go against having too high of a price. So that's what's going on here, and I'm going to kind of walk you through the analysis. So now you have to find the zeros of this revenue function. Find out when the revenue is 0. So 0 is 800, that's a 0 there, plus 50x, and you're looking for x's. Now what can you do? You could multiply this whole thing out and solve using the quadratic formula, or you could observe this is already in factored form. You have the first factor here, the second one here. Set each to 0. So first you go 800 plus 50x equals 0. That's your first value. Go over here and set 20 minus 2x to 0, and that will give you your x2. Those are the 2 times in which you have no revenue. What do they mean? Because later on you have to kind of answer that question. Okay, for this value of x, which will be negative, this will mean your price is 0. Well, okay, you can figure what that means. That's why you have no revenue. You charge nothing for your apartments. In this case, nobody rented the apartments. So as you change, either raise or lower the rent, if you lower it too much, you're going to give it away, and so you'll have no revenue. Here, you will have raised the rent so much that everybody moved out. So again, you have no revenue. From the previous problem, number 13, you ended up with x1 and x2. Those were the 2 roots. So one was over here, so here's your x1, and out here was your x2. The question is, using the symmetry of the parabola, find the value of x that maximizes revenue. Okay, well actually this is a parabola opening down. The value of h is going to be halfway between these 2 values. So here's your h, and that's what it's looking for, the value of x. At the vertex, wherever that is, hk, that's the x value at the vertex. Here's the y value at the vertex. So you average those 2. So you get halfway in the middle between them, and that will give you, doesn't look that way on the graph, but you get halfway between. That's where your h is. What is the maximum revenue? You put the h back into the original equation. So here was your revenue, 800 plus 50, and now put that value of h here, and that's 20 minus 2 times h, and that will give you k. That will be your peak. Here's another break-even analysis, but it's quadratic. The break-even analysis that we did before were linear functions. So your revenue, so kind of down here, your revenue looked like this, your cost looked like that. You find where it crossed, and that is your money axis, and here's the number sold. That's a linear. because you're dealing with straight lines. That's a linear break-even analysis. This is quadratic because the functions that make up the revenue and the cost have an x squared term in them. So their graphs are going to be parabolas. I'm going to show you approximately what that means. Okay, here's your money axis again. Here's x. Notice the negative sign in front of the x squared. This is a quadratic function. This is a parabola that opens down. Right? So when x is 0, I still have no revenue. So my revenue function is going to look something like this. Okay, just go ahead and graph it. All right, when you get to that point. The cost function. Let me try to change color here. I have to go. There's red. Okay. Now, when x equals 0, the cost is here. But look at this. This is a parabola that opens up. Well, I'm just going to draw a representative one here. Okay. It might have a piece over here, but who cares about that because you don't make negative items. All right. So here's your cost, and this one was your revenue function. How many break-even points do you have now? You've got one right here, and you've got one right here. You see, this is a more complicated analysis, but it is much more interesting. When you're in this region here, you're losing money, fine. But out here, you're also losing money. The only time you have a gain is right here, when your revenue is greater than your cost. So this is very interesting, and so it's a little more complicated. Why do you have quadratic revenue functions? Because you offered discounts. Those often turn up as quadratics. Why do you have this quadratic term here in the cost? That means the more you do, the more you lose. Generally, you have inefficient workers. Okay, so when you push them too hard to make too many items, they break more stuff, steal from you, whatever, get angry, don't work so hard. So it actually costs you money after a while because of the inefficiency of these workers. So you're going to analyze this situation here, and the problems walk you through it. So here you have, you sell the product for $108 right here, but you give discounts for large orders, and that's why you end up with this revenue function. The cost to make the items is very low, $8. Look at, you're charging $100 more than it cost you to make them. That sounds like you should be making tons of money. You have to pay $2,000 a month rent. Well, if you sell enough stuff, that should be taken care of soon. But the workers are slow, and if you push them to make too many items, problems happen. And that's this little inefficiency term here, which doesn't look like much, but really causes a lot of problems later. Okay. All right, so how much? He usually sells 150 of these per month. Well, it looks like you're making $100 profit, maybe, if you don't take anything else into account. So that would be quite a bit of profit, right? And then you've only got to pay $2,000 a month rent. Looks like things should be good. Right, so let's see what happens. This is a complicated problem. If you have trouble with it, you can contact me. I'll be going over it several times in class as well. Basically, just hang in there and keep working. That's the main thing you've got to do in this class. Just hang in there and keep working. You can read through this and you can write the numbers down on the side. You'll be able to organize it. I'm here to help you, but I want you to be able to do these application problems because that means you took something away other than just play with numbers in the corner, because that doesn't do you any good when you get to chemistry or business or wherever you're going. You've got to be able to know how to use this, and that's why I give you these problems. Okay, so the first thing here is to write the profit equation, and I give you the answer. Well, how easy is that? Okay, what is the problem? Here's the problem. Write the revenue down, and the revenue was minus 0.4x squared plus 108x, that's right. And now write the cost down, but you have to subtract all the costs, so you have to put parentheses here, and this is where people have a little bit of a problem. 0.6x squared, it was 8x, and then 2,000. Okay, I'm having to look over here and remember what it was. And now that negative sign has to be distributed through. I used to be able to change color on the fly, but I can't. Here, here, and here. Here's what people do and get in trouble. Minus 0.4x squared plus 108x, and they say, oh, subtract the cost. Minus 0.6x squared plus 8x plus 2,000. Did you subtract all the costs? No, you end up adding in those when you were supposed to subtract them. Okay, that's the problem, and that's where I gave you this information right here. So we've given this equation, and we have to find the vertex of the profit. Is this a quadratic equation? Yes. You see the x squared. That means it's a parabola. See the negative sign? It opens down. So to find the vertex, we have to put this equal to 0, because that's what we're looking for. Here is the h and k. So I have, oh, wait a minute. Okay, let me back up. I'll make an editorial comment in a minute. This is what I'm going to do right now, and I'll show you why. Okay, my editorial comment is this. I could do these videos, and as soon as I make a little boo-boo, I could change a video or edit it out. But I think that's real artificial, and I think with this distance learning, one thing you miss is seeing the instructor make a mistake and recover from an error. What is more valuable, never making a mistake, or thinking you'll never make a mistake, or knowing how to recover? I think it's knowing how to recover. So at any rate, that's why I don't make these perfect videos. Besides, I'm pretty far from perfect anyway. So okay, here we go. You need to find the vertex. There are two ways you can find the vertex fairly easily when the equation is in this form. One way is you can find the roots. That means you can solve for 0, and you can find your x1 and x2, fine, and then you can go back through this x1 and x2 and average them, and that will give you your h, and then you put the h in the equation and you get k. The second way to find the roots would be to use the quadratic formula, and remember or realize that the first term minus b over 2a, and here's the rest of the quadratic formula, which is why a second reason that I'd like you to write it in this form is this term right here. This is the h. So let's do that. Let's do it that way and solve this equation using that form. So I'm going to write, I have to write it equal to 0. So 0 equals minus x squared plus 100x minus 2,000. Alright? And now I'll say that h is minus b over 2a. So I've got the 100 here, so that becomes minus 100. 2 over a negative 1. A is negative 1. Remember the invisible 1 here. So that means h is 50. Then I take the 50, put it back in this equation, and I would find k from that. That would give me the vertex of the profit equation.